All right, guys. So this is just some biological reductions of ketones. So musk right here, it's huge in the perfume industry. This is reduced right there. Secondary alcohol, you can see the reduction. Fluoxetine or Prozac, which is down here, begins with this compound and eventually gets to here. Pyruvic acid plays an enormous role in the citric acid cycle, and NADH is a um, coenzyme. It's a reducing coenzyme, so it's going to undergo a reduction. So here, if we reduce our carboxylic acid, which is the um, you know aldehydes get oxidized to this. So if we reduce it, we're going to end up with an aldehyde, and down here we have an aldehyde that we're reducing back to an alcohol. All right, slide 11. Okay, these are kind of important. It's a big to do because this is how polysaccharides are put together. We're talking starch, sugars, all that stuff. And we really need to talk about that later on. So here, an acetyl, all right, is when an aldehyde reacts with an alcohol. Got it? This is a hemiacetal. You can see we have our R prime here. All right. This O stays on top, becomes an alcohol. This H swings to the bottom, stays the same. And this O attaches to the carbon, right? And we got our R prime out here. But then it can happen again, all right? Happens again, we get another one. This is a hemiacetal, all right? We have our OH, our alcohol group, and then our OR prime group, okay? If we jump over here, this is an acetyl, hemiacetal, acetyl group. Down here, we can do it with ketones as well. Same thing, except this R prime swings to the bottom. R double prime with the O is right here with the OH on top. Let's do it again. O R double prime, O R double prime. Down here, we're going to go through this. All right. This is 3-pentanone. It's 3-pentanone because carbonyl groups on carbon 3 reacted with methanol. What we get is a hemiacetal. This O becomes an OH, and this, remember, there's only one carbon there. That O attaches to this carbon, and we get a 1-carbon chain coming off. We can do it again here. Hemiacetal, acetyl group. We can do this with an aldehyde. The only difference here is that for the ketone, we have this branch chain. For the aldehyde, we still have H all the way through. Hemiacetal, acetyl group. There we go. There are several examples that we could walk through there. All right. So here we could start identifying hemiacetals and acetyls. All right. So for lactose, side note about lactose, it's a sugar, it's a polysaccharide, and people that are lactose intolerant, their body doesn't produce the enzyme needed to break this down. So here, right there, that is an acetyl carbon. We got our O to a carbon, our O to a carbon, and there we go. This is an acetyl group right there. Okay, and that's the only one that we have here. Actually, sorry, this is our hemiacetal carbon. There's our O to a carbon, and there's our OH. So we have an acetyl carbon and hemiacetal carbon. Oleandrin over here, acetyl carbon. You can see it looks fairly similar to that one. Boom, acetyl carbon, and that's it. Nothing else. As we jump down here, acetyl, 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 and that's it. So we have 3 of them. Digoxin, this is a poison. All right. So hopefully that makes sense.